to Director Oskar Karczewski, who will comment on the outcomes of the preliminary Polish gathering of ideas on the experiments and some small announcement, and then we will give a floor to ESA experts to provide you with all necessary details and answer all the questions you might have. So first of all, I would like to underline that we are entering a completely new level in our participation to European Space Agency. We are entering human space flights at full speed. This is a great opportunity, but also a great challenge to all of us, because this is something we will do for the first time. And by us, I mean every one of us is going to do that, both the administration, science and industry will do that for the first time in history. We have never flown together self-standing, sophisticated experiments on the International Space Stations. So we are very happy and thrilled to explore new frontiers and to boldly go where we have never been before. So with that, I would like to inform you that we are 128 at this time. So I will ask you to stay muted when you are not speaking, and let me give a floor to Director Karczewski. Oskar, the floor is yours.
Thank you very much, Alexandra. I would like to give a very warm welcome to a delegation from ESA, and I would like to equally well and warmly welcome all the representatives of the Polish space sector. It's a great pleasure to have you all here. Alexandra has mentioned 120, 130 people already. It's really fantastic to have you all with us today. I would like to make a few comments on the call and consultations that were organized by the Polish Space Agency in July. The call resulted in 57 submissions, 57 pieces of information from the Polish space sector, 57 ideas that were communicated to us. This is a great result. This shows the level of interest. This shows the level of ambition of the Polish space sector. As Alexandra said, this is a very special moment in the history of the sector and of the Polish space community. We are very happy that you are with us, and thank you for all these ideas. The ideas were very high quality. They were offered a great range of experimentation and technology verification tests, which is really the purpose of this opportunity to perform experiments on the International Space Station. So there is a great opportunity ahead of us. Today we will hear more details from our colleagues from ESA, more details on the technical aspects of the experiments that can be performed. Our colleagues will be open, and so will we. But this is primarily an opportunity to speak directly to people who have first-hand experience in preparing and overseeing experiments on the ISS. So please use this opportunity, listen to the information that will be provided today, and please feel free to ask any questions. Do not hesitate to take part in the discussion. So very warm encouragement to use this opportunity to interact directly with our colleagues from ESA. There is a small and short announcement from Agnieszka Kuczała, who is the Polish delegate to the PB HRE, the exploration program. If you allow me, I would like to read this short announcement in Polish, if that's all right. Thank you. So just a very brief note from Agnieszka Kuczała to the Polish space sector. I will read this in Polish. Szanowni Państwo, dzisiejsze warsztaty będą dotyczyły obecnego naboru na eksperymenty na Międzynarodową Stację Kosmiczną. Będą skoncentrowane głównie na kwestiach technicznych. Chcielibyśmy jednak dać Państwu okazję lepszego poznania całej gamy możliwości, które daje program eksploracyjny ESA, aby w przyszłości w pełni z nich korzystać. W tym celu 13 września organizujemy dzień informacyjny z udziałem ESA. Tematem tego wydarzenia będzie nauka w ramach programu eksploracyjnego ESA. Zależy nam na jak najszerszym udziale wszystkich potencjalnych zainteresowanych, przede wszystkim naukowców. Dlatego przed dniem informacyjnym, który odbędzie się stacjonarnie w Warszawie, planujemy zorganizowanie telekonferencji wprowadzającej w temat eksploracji w ESA. Dokładne informacje będą rozpowszechniane możliwe szeroko już wkrótce. Więc 13 września, Szanowni Państwo, dzień informacyjny z udziałem ESA. Prosimy o zapisanie tej daty. Dalsze informacje będą dystrybuowane, udzielane bezpośrednio przez panią delegat Agnieszkę Kuczałę. Bardzo dziękuję za Państwa uwagę. Thank you very much for your attention. I'm sure the workshops will be extremely informative and useful. And again, a very warm welcome to all of you, and let's have a good meeting. Thank you.
So, Alexandra, do you have anything to add from your side before we start, or do you want us to start from the ESA side?
I see that there might be a connection problem for Alexandra. She seems frozen. Let's give her a minute. Alexandra, do we have you with us? Do we have a colleague of Alexandra's from her department, just to confirm if Alexandra can?
This is Marta Walter speaking. I think we can just go ahead with the ESA presentation.
Okay, so thanks a lot for this big attendance in this workshop this morning. So we're really overwhelmed to see so many people attending. Can you hear me well? Let's start with this question, because we have a meeting room here, but we could not connect the meeting room to the meeting. So let's see. Can you hear us well?
We can hear you very well.
Yeah. Okay. Thanks a lot. So we're having several people here today. So my name is Julia Weiss. I'm the Utilization Planning and Payload Integration Team Lead in the Human and Robotic Exploration Directorate. I'm here with a lot of colleagues from the science team, from Payload Integration, and also with my manager. And so she would also say some words to you, but I need to hand you over 1 second.
Hello and welcome. Good morning to all of you. And as Julia said, I'm really happy to see all of this interest in these Polish activities and with the flight of the Polish astronaut. So here in this group, we're used to supporting all of the science teams for the entire Directorate of Human, Robotic and Exploration, as well as developing payloads for our various platforms. So our work spans from ground-based facilities and doing studies such as isolation and confinement research and bed rest and dry immersion studies, drop tower experiments, sounding rockets, parabolic flights, and certainly experiments on the ISS that we've been conducting for more than 2 decades now. And so, yeah, now we're really excited and interested to see all this interest from Poland, from the different science teams and also Polish industry. And we see the interest in really boosting the activities that are being conducted in Poland. And we're very happy to support you on all levels. So today you'll hear more about what it means to launch a payload on the ISS, the overall end-to-end integration, and the different support you can get from our teams in terms of defining your science requirements, the various constraints involved in having a payload on ISS, and what it means from all aspects like engineering integration, safety, logistics, and all of this. So I hope you find it really helpful. And of course, we're here to help you along in this process, because I know it's not easy, but we also really want to encourage newcomers and hope that with our support, you can learn a lot from this experience, and we have many years ahead of us to collaborate. Thank you.
Thanks a lot, Kirsten. Yeah, so I think we received already a lot of questions via the OSIP tool. So we try to have some answers of these questions and some general overview covered in the presentation. And I hope everyone understands that you don't need to understand the whole process and have answers to all your questions already now for your application in the tool. So at the moment, you can still have open points and open questions. So you don't have to have everything covered in your application. I think this is very important from what we have seen from the questions, because we will then help you to get everything ready and help you to understand what are the constraints and the interfaces. So the presentation may be, if you're really new to certifying payloads for spaceflight, it is a lot of information. So don't get overwhelmed. If you have questions, please raise your hand. I will start sharing the presentation, so I might not see it. So if I will ask my colleagues in the room to let me know in case there's some open hand, some raised hand, let's say. And at the end, we have, also questions for things that might not have been covered in the presentation. And also we have Angelique van Ombergen here, so you might have had contact with her in the OSIP tool, so we can also answer some questions about the science and the tool and how the process proceeds. So we'll have some discussion about this after the presentation as well. So give me a second to share. Can you see it online? Yeah. Okay, so let's get started. So the goal is to give you a really brief overview, because it is really a lot of process and a lot of things. So we will have very little information for everything, but it shall help you to understand a bit what is coming. So we had also a lot of questions about what is available, what are the constraints, what is the situation. So in general, the goal is to have most of the activities happening in our module. So in the European module of the space station, that is a Columbus module. And this is how it looks like usually. So it is a lab, it's a laboratory, but it needs to be understood that a laboratory on the station is not really the same thing as a laboratory as you have it perhaps in your premises or in your universities and institutes. So it is a bit more difficult to find the right facilities perhaps as well, and to find the right place. So you see at the end, this is the end cone, and then we have racks, and in these racks we have the facilities at the side. You can have experiments in the racks, you can have experiments also in the center aisle. So in the center aisle means where you see all the things that are hanging around there. Sorry, you will see sometimes an easier a schematic of the module, because it's much easier to work with the schematics than to work necessarily with the pictures, since on the pictures it is a bit more messy. So we have the end cone, and then as you see, besides and rack. So we have one CASA rack. This is a sleeping position in Columbus. We have human research facilities from NASA, and we have EDR2, where that is one facility, but when your mission will start, you will see soon it will be on another location. We have some zero storage racks, so we have system racks. So there we only have storage or system activity, so it cannot be really used to put something inside. And then we have some more racks like fluid science lab, a biology rack, and another European TRA rack that is for more activities. So you will perhaps see again more or less something that looks like this, so where you see a schematic of Columbus to understand better and to see better what we are talking about. So if you see like things like O2, F2, and so on, are the locations in the module. So we have an overhead location, deck location, forward locations, and aft locations. So there's a lot of also way how we talk about it. So, and I just wanted to give you an idea how it looks. And you need to understand it's really a working place. It's a laboratory. There are people working and living there. So it is not as easy as it might be in your lab. There were also a lot of questions about external platforms on OSIP. So we have also some external platforms and external locations, but it needs to be understood that it is much more difficult to integrate and certify something for external use than for internal. But in general, we have the EPF, the European platforms outside. So there we have 4 locations. You see them here called SOX, SOC, SDX, and SDN. The SDX and SDN locations will be mainly used by our own facilities. We have ASIM, one facility that is called ASIM, and we will have another one that is called ASIS that will be located there. And also these locations are for really big facilities. So it's not something for small cameras or so on, it's really for bigger facilities. But there's also a commercial platform. You can see it here with the Bartolomeo platform. So this is this whole thing. And this is belongs to Airbus, and this is a facility that is also meant for smaller payloads that should be placed outside and have a viewing location either to the Earth or to the sky, to the universe, and there you come. But of course, to bring something outside, it is also not so easy. I mean, if it would be a bigger facility, as you can see in one of the locations here, then it is usually taken directly from the launcher robotically to the location. If it's something smaller and that goes to the Bartolomeo location, then you need to put it outside through an airlock. So what you need to understand is that all this is much more difficult and also much more expensive. So if someone really wants to go for an external location, we need to discuss how this is being budgeted. But I mean, of course, we will do this when we look into all the applications, and then we see and discuss together, ESA together with POLSA, what is possible and what's not, and what options are available and not. And if you're interested in this, also for Bartolomeo, of course, you find a lot of more information online that gives you an overview about how big each slot is and how this is all supported also by Airbus, that is a commercial entity. So then inside we have also, I was talking about the racks before. So we have a fluid science rack and we have a biology rack and a European TRA rack. I will not go much into details here because they are usually meant to host really bigger facilities that are already planned and there. If we see one or the other payload that might be a user for one of these activities, of course, we take it into account, but we don't really, I don't go here into details because I don't think that it will be so relevant. So, but what might be other facilities that might be hosting facilities for you? There's another commercial one, that is the IceCubes facility. Also here you find much more information online if you're interested. And there, you have like little cubes where you would have your experiment inside, and these cubes can go into the facility, and you have then data, power, and so on provided by the facility. And there were also some questions: which temperature do we have in Columbus, and what kind of chambers do we have? It is not that we have really like chambers that were asked for, like a vacuum chamber or heating chamber, but we have an incubator. So you see here, this is a cubic incubator. It can serve or provide temperatures from 6 degrees Celsius to 38 degrees Celsius and provides power and these things. And you see, usually we have then the experiments in these little experiment containers. This is meant for life science experiments. Then we, of course, have also some assets that were asked for, or where you ask questions for, that are not ESA assets. So, of course, we also have access to the partner facilities and the partner modules. So it is not excluded that you can also use other things that are not belonging to ESA. But of course, then we have to find agreements, and you will see some more later how it works. And it's usually also then might be connected to a price tag, so we need to see what is possible and what not. So we have the cupola. This is something that is usually used for the crew, and the crew is there, shall use it for their free time and so on. So we can use it for picture takings, for experiments, but only for a very limited time frame. So if you had in mind you want to put something into the cupola and leave it there for a long time frame, to take pictures for a long time frame, this is not allowed. So it's really only for very limited time frames, and we need to see what is really possible and what's not. There are other windows, like the one you see in one of the other pictures, where it is possible to put really something in front of the window for a longer time frame and doing science experiments or education activities there. Then there were also some questions for cold storage or conditioned storage. So they're not only the incubators, but of course there is also a freezer. So here you have a picture, an example for the Melfi freezer. This is a minus 80 degrees freezer. And of course, you have to have in mind it's also limited space in there. So you need to really, and we will help you with this, what are the dimensions your samples can have if they need to go to a freezer. And it's really a very valuable resource on the station. Is there a question? No, okay. Okay, so then let's go from how it looks there to the processes. So I will give you a very brief overview about all the points that you see there on the thing. So this is more or less all the processes you have to go through if you want to certify and develop an activity or a payload and an item for the station. So we will go one by one. So I will give you a very brief overview about everything. And if you have been selected and we go ahead with your investigation, we will help you to go through all these things. So you will get support for everything. But it's important that you understand that there are processes for everything. It is not really easy to get access. So we need to make sure that everything is safe and secure and possible and operationable, feasible. So be prepared that there will be like a year with a lot of work in front of us. So the requirements, and so once we have asked you to fill in something that is called the activities requirement document. So this is we ask you to put it already into your application, because this will speed up the process a lot. We know that it will not be in a very mature state necessarily once you now put it into the OSIP system, and that's fine. We can help you with the details later. But it's very important for us to have already a good understanding and to have already a draft, so that we can really speed up all the other processes, because this is really the requirements definition is really at the beginning. So if we don't have a good requirements definition, we cannot go ahead with anything of the other processes. You will get either you get someone from the ESA team, so project scientist or payload integration manager, who will help you with the ARD, who will be your book captain and support you in finalizing it before it goes into the official review. So we will have kind of an offline review, and then we will have the official review in the system. And in the end, then these documents will be approved by the UIB, so by the Utilization Implementation Board. implementation board. So somewhere on the later slides for your reference. And it's very important that you have really clearly defined requirements from the beginning, and that it's streamlined, and then we have a good process. If you change everything later and later, and you do it in a very iterative way, then we might need to change everything again, based on the change requirements, and this might take too long to get you ready in time. So wait a second. So hardware development. A hardware or activity development will be mainly your responsibility. You will get support also here by a dedicated by the payload development team that we have. So you will have some guidance and you will have support, but also it will be a lot under let's say under the entity that is selected to build it, and we want just to flag that you should keep us always very closely connected and keep us in the loop. So make sure that we always know what you're doing in case you're changing something. So in general, you need to close all the verifications for all applicable documents. We need the schedule, and to make a feasibility assessment to understand if you are aiming to do. I mean, there are two options. We select your payload to run it in the Polish mission when we have the Axiom flight. So then we need to see if it's possible that you are really ready for this flight. If you are selected for a long-term activity, then of course you also need to understand when you need to provide the safety data packages, flight acceptance data packages, and so on. And I will give you some more details about this in a later slide. And for agreements, so I think I mentioned this a bit already before. Of course, ESA has an agreement with POLSA to work together, but we will also need to make some agreements with you. So you will see that we might need to make some contracts, like for the payload development, or sometimes also if you might need some more equipment. We need to see how we handle this, but we will have agreements between ESA and POLSA, potentially also some agreements with you. We might need some agreements with another international partners. So if we want to use something from an international partner like the cupola that you have seen, or the freezer, or something else, then we have to have an agreement with the international partner, and we will have a payload integration agreement. So here we will also, of course, support this process, and this will be done via ESA. Just then need your inputs, and we will work it very closely with you. Engineering integration. So this is also very important because there were a lot of questions about interfaces in the OSIP tool. You don't need to define and know all these interfaces already now when you are applying in the OSIP tool for your experiment. So I will give you some examples here, but we will identify together with the engineering team which interfaces you can use and which are the best interfaces for your payload, and how to add it and how to work it in the stations. But in general, of course, we have mechanical interfaces. You can be attached to a C-track, or you can be attached with a bungee, perhaps even inside a rack, depending what it is. The module can support 120 volt and 28 volt outlets for your hardware. We will guide you how the outlets are looking like. I mean, we have also power banks, things like this for smaller things. We have a LAN on board, we have Wi-Fi on board. So there are connections available, and we will tell you, or the engineering integration team will tell you, which interface control in the interface control document, how your interfaces will look like, and which how you can provide a closure evidence that your requirement is matching with what we provide, so that it's really confirmed that when you fly, that this will work. And also, of course, for the launcher, there might be some requirements that you need to be compatible with. So vibrations and all these things. So, but you will get a requirement document. Some of you might have even gotten it already, some constraints, but we know that it's not easy if you get the whole document to understand what is really applicable for you. Ground and onboard communication. So there is communication. I think there were also some questions. So you can have data uplink, data downlink. We have voice support during operations with the crew. We have Wi-Fi, Bluetooth on RF capabilities. But it's very important to understand that to integrate this takes a lot of time. So we need to start with this quite soon. So especially, I mean, everything that can communicate wireless, it really goes to the security and all these things and to the frequencies. So it's quite a long process. And also, of course, we need to see how to connect it with the ground segment and so on. And we have some devices on board that help you. So of course, we always motivate you to use what is available and what is easy to be used, and not to have something totally new that takes a lot of time to make it work. Data can be needs to be protected, of course. So depending on what kind of data, the levels are different. So, but if you, for example, have personal data from the crew member for your experiment, if you do some human research, we have really sensitive data, and we have then also a lot of data protection that needs to be put in place to make sure everything is safe during the transfer and the storage of the data. And this goes then directly to the safety and security. So safety means that something that you upload, operate, download, store is really safe. So we do the safety review ESA internally. So it's done by ESA only if we have an activity or a payload that is connected also to a partner's device, and we have an integrated safety review together with the partners. As soon as you have been selected and we have an overview or a baseline what you want to do, you will meet the safety team for a kickoff meeting, and then they will go with you through everything and define with you what you need to do to have safe operations and a safe payload. So the safety process is 3 phases, and every time you need to submit a safety data package. It will be reviewed by the safety team, and then they will approve it or not approve it, or approve it with some things, and you might need to do some changes. Here it's very important that we also start this as soon as possible, so that we have the chance to get ready for the flights. And it's a bit iterative process, so because of course it goes more and more into detail the closer you come for your final safety approval. And so safety is more for your hardware, so make sure that it's safe, that you have all the levels of containment if you have something toxic, or that the crew cannot get hurt by the payload, and that the station cannot be impacted by it in a negative way. And security is more for the software part. So everything that is operated needs to be also secure, so to avoid that there's breach of security and someone gets access to the system and so on. So it's also, there's a question? No. Okay. So I will make a short stop after this one. Also here you will get in touch with our security team, and they will help you and guide you through the process and explain what you need to do to have your secure software. And
to share the slides.
Yes, the slides will be shared after the meeting, so you can have it for your reference and have a look again. Of course, I know it's very quick. We go through it very quickly because, of course, we also want to have some time in the end for your questions. So operations. So ESA will assign an operational entity that helps you to do the operations on board. So most likely this is a user support operations center, or ECOS, that is something similar, or sometimes it's just the flight control room and so on. Because we know that there are certain rules and products how operations needs to be performed on the station. So we have procedures for the crew. We might have commanding via scripts. You see here like a control room in one of the user control support centers. It's Catmos. So we have a certain way how to command and how to get data down. So everything needs to be linked to an operational center. So we will assign someone, and this team will then go and start with your ARD and also with hardware, user guides, things like this, to build these operational scenario, to build the timeline for the crew member, and to develop the procedures and all these things. But of course, this needs also some time, so they need to have this information also quite some time before the activities start. So we are usually 5 months before the start of the activities. We already start to do the planning and all these things. So also any models and any information that the operational teams need to be available fairly early. So as soon as possible, we would like to start with this. And then there were also some questions. So how much time will we have? I mean, what is possible on board? So the operation, so the mission itself, we assume that it will take around 2 weeks, perhaps 10 to 14 days. And in this time frame, let's say we have the crew member that is on this Axiom mission for our activities. It's about 60 to 70 hours in total. So this crew time needs to be shared with all experiments, all investigations that we want to do during this time frame. So this will be the national contributions, but these will also be some activities from ESA, and we need to see sometimes it's even activities for other partners. Not necessarily during an Axiom mission, but it's possible. So it sounds a lot, but it's a lot for a short time frame. But on the other hand, of course, if you have a lot of activities, and it's not then so much before. And I will have another slide where I say some words about how much access you will have to the crew member before and after the flight, because I think this was also asked. So it will be very tight. I don't have I didn't put a picture here, but the crew member will really, in these 2 weeks or 10 days that he's on board, he will have it every day. He will have like a schedule, like at school, like where it just tells him what to do. So it is a really strict pattern, and operations will be really strict. So this is just for you to understand that it's also important that you are available in that time frame, and make sure if you need your support, that this is something where we don't have much flexibility. So for human research, so if you want to do anything where you have any medical data from the crew member, it can be a really like kind of human research experiment, but it can also be something that you have, it's more like a tech demo only, but you still want to have some data that the medical teams be sensitive personal data, then you need to go through the medical board process. So then, because it means the life science research protocol needs to be followed, and all the medical teams need to approve your experiment, that it's ethical and that's medical safe. And also all the human research that is done needs to fit together. So it's not like we can have 10 different experiments that needs 1 liter of blood on the same day. So of course we need to make sure that it's compatible with each other. The crew needs also to agree to participate, but before we can ask the crew to agree to participate, you have to have the approval of the medical boards, and this takes quite some time. So here, this is also something why we need to have your activities requirement document approved as soon as possible. So if we have a human research project, that we can go ahead with all these processes to make sure that we get the crew consent in time, and then also have time to do pre-flight activities if you have any. So if you want to measure the crew, let's give an easy example, the crew height before the experiment, on the station, and after the experiment, then you need an approval for all this, and this needs to go through this process before you can do it. And not only for the medical, and usually we do this when the crew is at EAC, like in the European Astronaut Center. So we can do this like BDC, so the pre-flight sessions, also somewhere else, but usually for our activities we do it when we have access to the crew at EAC, and this is very limited. And this is also important for the training that is relevant now for everyone again, not only for the ones that is human research. So they will be trained by our trainers, because also there it's a very experienced team that knows how to train things for a crew member. They know how to do this in a really good way so that we have a good outcome. So the goal of all this is to have a successful mission and have your successful operations, because we only have these 2 weeks where the crew can do something. We cannot see, oh, we did not do this very well. We realized we did a bad training, bad procedures, and oh, there's also a failure in our payload. We need to fix it all and do it again in 2 months. This is not possible. So we really need to make sure that everything is going well from the beginning. And of course, the crew does not need only to be trained on your payloads. They also need to be trained on the station, on the Columbus module, on the Dragon capsule. They need to learn a lot of things in a very short time frame. So also the training, the schedule for the crew is not only very constrained in when they're flying, but already when they are in training. So they come to the ESC, if we are lucky, 2-3 times, depending on the schedule, and then we need to be ready to train them. And so everything that we need, so if we need a training model and we need your procedures and all this, it needs to be ready before, and needs to be provided to the training team before, so that they can check what kind of training is needed. And sometimes it's easy, it's not a big thing, but sometimes we need really some training, and then they need to make sure that the training is in good shape when the crew member is coming, and then we can train as much as possible in the limited time frame that we have. There is a possibility to train on board. We try not to do it because the crew time we have on board is really limited and very valuable. But of course, worst case, it's an option. We did it more when we had the COVID restrictions in place, because there we had much more remote training and onboard training, because the crew could also not travel so easily. But it's really only for very limited cases. Logistics. So logistics means, how is your payload coming from you to the station? So, and also here we have a service, and the service will be available for you. So it's important to understand that it takes time, and that we have to have the hardware available quite some time before the launch. So, and because there were some questions, okay, what if we heard rumors that the mission might be a bit later than it's shown at the moment, and these things, and that's true, and I expect that it might be a bit later than the May date that is the official date from Axiom. But even if it is later, your hardware needs to be ready in May. So presumable, depends of course when the flight is, but you need to be ready quite some time before. We need to make sure that the packaging is correct. You will see that it needs to be labeled. So everything that's on the station is labeled, so that if something is found, it's clear to whom it belongs, and so on. Also, the references and the procedures are with the labels. We need to understand what are your transportation requirements. Is there something toxic? Do you need cold conditioned storage? Can you get an X-ray at the airport? We need the import permissions for the US, because you're not flying from Europe, and this is also not always easy, depending, especially if it's something with life science or biology or toxical things. Will your payload return or not? Will it be trashed and so on? And this is also something you have to have in mind. If there is not the need to return, we will not return, because it's already a very constrained resource to upload items to the International Space Station, and to returning it's even more difficult, because there are more vehicles that go up than vehicles that can bring things down. A lot of things just will be trashed. So be prepared to do all this and to be ready in time. You will see a bit of timeline later as well. And of course, packing is also crucial, because of course, if we have only a certain amount of space, we want to pack as much as possible in this space, and things should be as light as possible, as efficient as possible. So integration in ESA and NASA complements. So this slide is bit special for an Axiom mission, but still, of course, just for awareness, we also need some documentation. So we have to work together with NASA and Axiom on documenting what we are flying, what we're doing, and they need to have this information also earlier than just on the day of the flight. So we're discussing this with Axiom and NASA. There are some processes, I mean, mainly we're following the nominal ESA processes, and it's very, for us, way forward, and we understand what to do. But of course, it's an Axiom mission, so we have also a lot of coordination with Axiom. What are we flying with them? What are the limits? They need to integrate the mission with the other Axiom crew members. So there is a lot of documentation. And so here you will need to provide us with a lot of information as well. Like you will be asked very precise information about all your dimensions, your mass, and how much crew time you need, because we need to put this all into a big system, into the orbit system. Here you see the change evaluation form. So there's a process how to put things into this big system, and there we read really precise information at a certain point in time. And before you can fly, we will have a milestone that is called the COFA, the Certification for Flight Readiness, where we will go through everything that we have seen right now and check, are you ready? Are you ready? Is this done? Is this done? What is still open? What do we still need to do? So this is to make sure that we don't overlook something, that we are safe, that we are secure, and that everything is in place. And important, and here is one of the milestones. Like 16 weeks before, we need to make sure, I mean, this is like when we usually need to confirm to NASA, and the milestone is more or less the same for Axiom, our launch manifest. So later it is really hard to have changes. Yeah. Okay, I will come to the questions a bit later after the presentation. I think they're more general, not for the slide or something. There's also some post-flight reporting. I will not go much into detail here because I think this is something that it's not so relevant for now. But of course, we also expect to get some reporting. How was your experiment? What are the results? And ESA is gathering all the data and all the results that we're having from all experiments. So, because of course it's a very precious data points, and we don't want to get these things lost. So this is an integration timeline, how it more or less nominally looks. You see, we have a milestone 16 weeks before the launch. And you see also a bit how long it usually takes to go through all the processes. Assuming the official launch date that we have at the moment from us, have of course a problem that we are here already. So if it really launches in May, we don't really have a whole year to integrate it. So this is why this brings me a bit to one of the questions that are there. So, okay, we hope it might launch a bit later because we know usually the flight plan is not yet stable, and we know that things are changing. But let's assume even if we have a year from now, it is a very challenging timeline. So, and this is a bit, there is a question, is it possible to extend the proposal submission to the deadline? I will give this to my colleague Angelique and to POLSA, because what needs to be understood is, like, from my point of view, every week we lose now because we leave this application open and we don't go to the next step. Because, I mean, Angelique will say some words about the next steps for the call, but there are a lot of steps still and quite some time that we need to confirm who has been selected in this application. So every week we postpone this, we will lose for this process. We will not get it back. So you might have a little bit better proposal, and perhaps you need it, and you need it perhaps to provide more data and more things. But have in mind, I mean, we all need to have in mind, we will miss it later. So if you're 1 week late for the launch will be gone. It will not help you. So just to give a bit perspective why we have a very short time frame for your application. So we understand that, and we even I mean, we even try to extend it as much as possible, but there is another end date. So we don't have time forever. We want to be ready for the mission. So we need to, at a certain point, decide, okay, now we stop with the applications and we go ahead and do the selection process. And then we go and do the payload development and integration process. And the next question was, who's bearing the SAS cost of operating the experiment in case of the... yeah, so this is something that we would indeed need to discuss. So this would be something that if we have some candidates who are thinking of using one of the commercial support, like Ice Cubes or Bartolomeo, we would need to discuss this during the selection process, if this is something that can be financed by the money that is available via this call, or if this is something that would not be included there. So this, I think, is something that depends a bit on the case by case, and also what is really, I mean, is it really like only the access to the Ice Cubes facility in comparison to having robotic operations to put something on the Bartolomeo platform. So it's not an answer I can give right away for that is true for everything. So it's something that we would need to discuss. And another question, would it be possible to mount the device outside the station? Yeah, I think this was something I shortly discussed at the beginning. Generally, it is possible to have payloads outside. And I mean, perhaps I can catch. Perhaps it was too short. Second my laptop. There are certain. I mean, the easiest to have something outside is, of course, to have it outside and at an external platform that is at the Columbus module. Of course, there are also other platforms, and it's also not impossible to use another platform. But let's say the further away you go, the more difficult usually it is, because it includes different barter costs or usage costs, much more integration with international partners. So we have some platforms that are belonging to ESA, and then there's also like commercial platform. It's possible. We would, if someone wants to put something outside, we will look into it really in the application to understand what for. I mean, what kind of platform you need, how big, how difficult it is, for how long. Is it something that can be done robotically? What would be the costs that are connected to this? Because it's not always the same. It really depends on the payload. Oh, I mean, there might be also something that cannot be done robotically, and you would need a crew member to install it somewhere very exotic on the station. So then these things are, of course, really much more difficult and not necessarily what we are planning to do. But if it's very interesting, I would also not exclude it right away. But you need to understand a bit what are the constraints, and then that we would really need to look into your proposal.
Can I say one thing?
Yes, of course.
On the external payload, we need to have a heavy collaboration with NASA.
Yeah,
and that takes considerably longer than what we can do for a normal payload.
Yeah,
it needs to be taken into consideration that even if everything is feasible, we need to consider that it will take much longer because we have to talk to NASA, to the robotic teams, and they have their processes which are very detailed, of course.
Yeah, and also there are usually other people, I mean, other entities who wants to do the same. So it needs to be checked when it really would work, which location. I mean, as my colleague Alessandro was saying, it is, we don't owe the robotic operations, we don't owe the airlocks and all these things. So this would all be something that if we use it, we need to pay for it. And then also the integration and the discussions are much more complex. So it takes longer, but it's not impossible. Okay, how long can the experiment take? Yeah, also here, of course, it depends what you do. You know, if you have something very simple, for example, radiation experiment, like just a little thing that measures radiation, to have this somewhere deployed in the Columbus module for 2 months, for example, is not really a problem. If you have something that needs to go into an incubator, if it goes into an incubator for 2 months, then it's already more or less difficult. it's possible. We have experiments that go to the incubator long, but of course, then we would need to see how it works, how it matches with our experiments, and so on. So, I mean, there is the Axiom mission, and of course, we want to have as many activities ready for this Axiom mission. That is only 2 weeks, but of course, it's not excluded that there might be something that starts earlier or stronger, or if we have something that we select also something together with POLSA that is implemented even to the outside of this mission. So it also depends. So also for human research, if you want to do something during this mission, then it cannot take 2 months because the crew members on board only 2 weeks about. If it's something else, then we can discuss. What is the pressure and the temperature in the cabin? So the temperature is usually room temperature. So, I mean, and there are people living there. So, I mean,
one of the readings from yesterday.
yeah. Yes. So, can you share it with me? Perhaps it's interesting. I don't know. So every day, and we will just share it so that you see how it looks like. So this is also information you can get. I mean, if you have an experiment that needs to understand what is really, you have it in the cabin and in the center aisle, and you want to know for every day what were the temperature and the pressure and so on, then you can get this report and this data every day. So this is not a problem. But in general, it's room temperature. You see here the pressure is 742.
No.
Yeah, atmospheric pressure. I mean, it's normal. I mean, there are also limits. If you have a payload, there is a pressure range that you need to apply it for. If you have sensitive to pressure, I mean to depressurization, I mean, of course, then we also have this information available. I mean, we will check this information, but usually this is not the problem. Yeah, it's all in the requirements document. Yeah. Any other question? I can check again. Okay. This one question is the safety process consisting of 3 phases: operations, preparation. Does this process look the same if we decide to integrate not with ISS directly, but using this commercial ice cubes facility or other proxy device? Would it change the timeline, or are these steps needed? And how? The steps are always needed, but of course they're much easier. I mean, if you are using something that is has a certain constraints, I mean, like an ice cubes, of course, an ice cubes facility, if it's not something very special, then it is do I share? No, I will share again, sorry. Then it will be easier than if you do something else. But in general, you have to go through all phases. If it's something very easy, something very straightforward, then the safety team can say that they some of the phases. So they can say we have a phase 1, 2 together or something, or 0, 1 and 0, 1 together. So, but generally it applies to everything. Does Columbus have any transparent in as rear window to observe the outer space grid? I don't understand as we are all anyone. Infrared.
Partly.
We don't know that. Yeah. So so, but we're not sure what you mean. But it does not have a window. So we have an aluminium shell around Columbus. So this is what we have. There are some windows, as we have seen before. I don't know if oh no, that's not the windows. They can be used for certain time frames, depending on how long and what you need to see. But Columbus itself does unfortunately not have a window. What can be paid by it's possible to use PC computers to the station to collect data from the device. Yes, that's possible. And indeed, I think there was already there was one question also if you can bring your own laptop as well. Generally, it's much easier if you take one of the laptops that's already available and you use your software on this laptop. It's easier than bringing your own device, but also bringing your own device is not totally impossible. I don't know if we did that last time. Does not really. when did we bring a payload laptop, a dedicated payload laptop? Because then you need to certify this laptop. This is a difficult thing. So if you use a laptop that is already there and certified, it's much easier to bring your software on this laptop, but generally it's possible. You see, for example, here are some laptops, and we have some laptops that are dedicated for payload activities, and you can communicate with this, you can upload software, of course, going through the security process and so on, and connect. There are also iPads that the crew members are having. So also here, there are options to have software or apps on the iPad. Of course, it takes quite some time, so this is something that needs to be kicked off very quickly.
And the easiest is to install the virtual machine on the computer we have on board.
Yeah, easiest is to use computers on board, have virtual machines, use your software on the computers, on the laptops or on the iPads. But there, Angelique, I'm also looking a bit at you. So the question is, what can be paid by grant, reagents, facilities, traveling to ESA for preparation, tests prior to the experiment, with details?
This is up to POLSA.
Yeah, so here, this is a bit something that we still need to discuss with POLSA. I think we provided as an answer to this question in the tool, provide everything that you would need. There's money that is more dedicated really to payload development. So the money that we are like having for there's a certain amount of money that is meant for payload development and everything that is connected to payload development. Of course, like also maybe also something that access to things that are needed on board. We can discuss this POLSA if the money can be used like this. Other money, like other things you need, like travel costs, things like this. This is usually with the space with the space with the National Space Agency that is supporting science teams. Put it in, and then we can discuss with POLSA when we do the application what is possible. So it's not straightforward. And I don't know if someone from POLSA wants to add something.
What's the deadline?
Reply? Friday evening, 8th of September. Are the mandatory parts of the RRD application or only those containing instruction usually highlighted in yellow? So we highlighted in yellow what they need to do now. Yeah. So it was clear that you may not be. It's not possible to answer everything. Everything that is in yellow, please try to answer it and to put something in. It may not be as mature as we want it or as it is needed, but we will work on it. But try to provide as much information as you can. And it does not need necessarily to be how it can be implemented. It can also only be what you need scientifically. And then we can find out how to implement it. If you want to,
I want to say like it's better to not put too much information in there.
Yeah. So like, for example, okay, I will gather 20 megabits of data with my payload. It's a good information. How you get this data down, you don't need to specify it necessarily. We can see what works. Is ESA BioPen device still available for biophysical experiments? I don't think so, since I have never heard about it. Anyone knows ESA BioPen?
Julia, this is Enrico. Can you hear me?
Yes,
yeah.
Enrico. We hear
so
you.
I think this facility was something that used to fly on the Photon missions.
Yeah, can you speak up a bit?
Yeah, I think this is something that used to fly on the Photon missions, on the retrievable capsule missions with the Russians. So I don't think it's really old. It's something I think that used to be managed by René Demetz a long time ago. So I don't think this exists anymore.
Okay. So thanks to Enrico. So we have someone who still knows it, but we have an echo here. Sorry, in case you get the echoes, but most likely not available anymore. how big a small cubic is. So the cubic, I will add I just realized that I don't have have it here. I think you can find it online if you Google cubic ISS or cubic ESA, but the cubic is like this. So but I can add the information how big it is inside, how the full volume is, and also how the volume of the ECs is. Perhaps we have someone who can answer it from the team. If so, speak up. Otherwise, I will add it in the info later. What will be the possibility to create vacuum or near vacuum condition inside the Columbus? Is combustion integration rack, for example, available for conducting tests? So we never did so we don't have a vacuum. We have vacuum. We can provide vacuum, so we have vacuum lines. So something can be connected to the vacuum lines, like the racks are usually, the big racks are connected to vacuum lines. And then we have payload facilities in the racks that have a vacuum chamber if it's needed. But it's not that we have a vacuum chamber that can be used for anything, like you might have it in a lab. So it is would really need to understand for what you need the vacuum. If you would need to build your own device, or if it's something that is compatible with the experiments we're having using vacuum. But I don't think so, because they're crystallization experiments and electromagnetic levitation experiments we are doing there using vacuum, but we don't have a vacuum chamber. The CERAC from NASA, we also never did an experiment there, so it can theoretically be requested, but it is also something that would include additional costs, and we would need to see how we do this with NASA. Okay.
Do you just take it outside and you have vacuum?
Sure. But you need to bring it outside is also not so easy. I mean, we use the vacuum from outside in our rack, so this is indeed true. I mean, but you need to get connected to the vacuum line.
Julia, maybe we can explain a bit this, because maybe the Polish people are not very familiar with this. So just what is the meaning of a vacuum line? I think just to explain, maybe I can say it, like in principle, we have lines in Columbus for venting and vacuum to the external. So we have lines which are connected to the external. And so in principle, every payload could connect to a quick disconnect, a QD. And so in principle, if the payload is a self-isolated chamber, it could be connected via a pipe to another pipe, which is connected to the external. And so you could create a vacuum inside your own chamber. But then, of course, the chamber needs to be, let's say, of course, for safety is a very critical point, right? And so it will add a lot of complexity for integration and safety, of course. But in principle, that would be possible. But the payload itself would have to have a chamber which is, let's say, self-isolated. It doesn't create a leak to the cabin, and then you could put in the chamber, you could create a vacuum using the external venting.
What's the mass limit on this experiment that you can take it there? Like how heavy can it be?
Yeah. So Sergio, do you have by chance
yeah, I mean, overall with Axiom is 10 kilograms, so it's not a lot. But of course, we need to see, because like we could be able to upload something with a vehicle before Axiom and then use it during Axiom. So it's a tricky question. For Axiom itself, it's a very limited mass. It's 10 kilograms overall for the whole ESA complement. And so indeed, making something that can be connected to vacuum, I was also thinking about it before. It's difficult because, of course, it means a lot of mass if you need something that is solid enough to be a vacuum chamber.
Yeah. So in general, I think we have some guidelines in the AO how heavy and how big and so on things should be. it's very crucial. It should be as small and as light as possible in general.
Yeah, we got that. Is there any chance for an extension on your deadline for registration? Because it basically leaves me 3 days to put something together.
This is I don't know. I will look to my colleague.
Yeah.
Yeah. I mean, put everything together as much as you can. I mean, if you say, look, I mean, there are things missing at the point of the deadline, we can also come back to you and ask you. I mean, it's better than not apply for sure. So if you miss some points and cannot put everything at once, we can get back to you and ask. But if you give a general, I mean, the point is, if you give a general extension, then, as I said, we will lose it at the other end.
Yeah. Because I got the link. In this announcement, there was a link, and I looked into it, and there were quite a few different things listed under the same link. Which particular program is it that I should apply that this thing falls into? What category does it fall into? Which one? Do you know? I got the, hold on a second. I don't know if I can.
Yeah, I mean, if you have very specific questions, you can still send them to us, and we can try to help you if there's something not clear in the forms that you need to fill. Yeah.
Okay, I'll do that.
Yeah.
No, I didn't read it through, but I will do that. We'll see what I can come up with.
Yeah, thanks. That's most likely the best way to proceed, and we can come back to you if there are things that are missing.
Okay.
There's a lot of question in chat.
Yeah. So let's see. Yeah, perhaps we need to. We will try to answer the questions in the chat later, and you can also see them later. I think. Let's see. There's some raised hands. The number 1, Agnieszka, 52539. Okay, not clear if it's so. Then perhaps, now we hear you. Yeah.
Okay, because this is I have a really controversial question because my experiment is a little bit larger than this ice cube facility. Like I wrote it on chat group, and I would like to ask if it's still possible, like, you know, that this experiment will be qualified. It have 70. The biggest the dimension is 75 centimeters. Like 75, 40, 50 centimeters.
It's quite big, but it's not, I mean, it's in general not impossible. So things don't need to go to one of the facilities I have shown. Things can also just be located in the center aisle of the Columbus module. So, but of course, so
it's possible, yes?
Yeah, possible. It is possible, but of course, when we see your application, we would also see what experiment you have, because perhaps it makes sense to make it smaller to fly in case it's something that you usually use on the ground.
Actually, this is first 8 modules, so it's probably not possible to make it smaller. Actually, we made it smaller. Like this is probably the smallest.
Okay.
The smallest version. So we can still apply.
It's not excluded. Yes, you can still apply.
Okay, thank you very much.
Yeah, and the real research.
Hello, Thank you very much for this webinar. I also posted the question there, but there are so many, so I decided to come here. Can you give more details about cell culture experiments? I know the IC cubes can do some of those cell culture experiments, but I know there is also the incubator. What we would be looking for is the control of CO2 plus the temperature at 37. So if you can give us more details on that, that would be very helpful. You are muted, sorry. I don't know if my question was heard, but you.
Yeah, sorry, we just figure out how to, because I hand the question over to someone else, how to unmute this.
Yeah,
So.
apologies, we have a bit of a complicated setup here in the room. So thank you very much for your question. In essence, we have capabilities on board the ISS that allow to have temperature control and environmental control. So there are possibilities. So what I would propose is to just include that in your proposal, state very clearly what your requirements are for the cells that you would like to test, and then we can also assess that in the application and the selection.
Okay. Then let's go. Do we have another one, or can we go to the next?
If I can have later some more questions, I have actually quite a list of them. So yeah, I will
put them in the
I'll
chat,
keep
and
it
then
up.
we can put as much in the chat, and then because then we can even answer them later today, and then we can see how much time we still have, because I know we. Yeah.
Be careful that if the people are not part of the Teams organization, they lose access to the chat after the meeting.
Yeah. Okay. We can. Yeah. Yeah. I think POLSA wants to make the meeting available, so I think we can then also make the chat and the answers to the chat available.
Is there a chance that someone at POLSA can collect all the questions on their site and send it to us?
Alexandra will.
Yeah, if I may, yes, of course, the meeting is recorded, also all the chat questions. We are trying, well, ISA is trying hard to answer as many as possible. However, I understand that some are specific and need some consultation. So on that, we will jointly work out so that you have to make sure that you will receive answers to all the questions you have asked, either now on the meeting or later through the chat, or later through the individual correspondence. And please, if you don't receive your answer by the end of today, contact us, and we will make sure that all your questions are answered as soon as possible. Thank you.
Cały czas może pytać, co z tym.
So Vitor Janik to the next question.
Okay, are you hearing me well?
We hear you.
Oh, okay. According to the schedule, I want to ask what is the deadline for providing ready hardware, or is there any possibility to consult possible modifications during the preparation for the flight after all?
Yeah. So usually the hardware needs to be provided for, 3 months before the launch. This is the undock date when the shipping needs to take place. Depends, of course, a bit if some things are only handed over at launch site, if it's something living. If you have cells, things like this, but usually 3 months before the launch, the hardware is handed over. And this is really what we are saying. If you don't have anything yet, and we need to develop the hardware, and we need to certify the hardware and do all the integration process, this time frame is very short. So let's assume we have a flight that is a bit later than what Axiom is showing at the moment, and you need to provide the hardware around perhaps in May next year. It's varying. It depends. Now, if the launch would stay in May, where it is shown at the moment, you would need to provide your hardware in February. That is like 5-6 months from now. So we really don't have much time. Let's assume we have perhaps 9 months or something. Then we are already in a better shape, but it's very soon. So we need to also to understand in your application, if it's for this Axiom flight, what is your maturity and so on. I mean, of course, we can have some experiments perhaps that are flying later and have a longer time for payload development, but then they will not be there for the Axiom mission. And if you are big, but you want to be there for the Axiom mission, we might need to upload you even before, then you have even less time.
So that the time schedule is tight, I have to say.
Yes.
For many,
yes, it is really tight. It is really tight.
Yeah, maybe this is something that we should handle. Okay, thank you very much for your answer.
Yeah. Okay, Justyna Topolska.
Hello, thank you. Thank you for this meeting. I have some question about possible help from ESA engineering in adjusting the laboratory setup to the low gravity conditions. I have in mind experiment that is very simple in laboratory, where is the bottle, there is liquid inside and mineral, and it dissolves. You take samples from time to time. But it would need to be adjusted to the low gravity conditions. Probably I can imagine there are many different ways you can run this very simple experiment that would not determine the results, but it would be easier for astronauts to manage with this. So where should I write about it in the application? That I need the help to adjust it, because, for example, bottle can be replaced with, I saw in some YouTube movies, the water disposable tubes. So there are many ways to run the experiment. Where should I write it, and if I can then get this help from your engineers?
Yeah. Okay, so perhaps so there will be a second step, and it says someone from the ESA payload development team in the meeting. Let me quickly check, because we don't have someone in the room, but there might be someone connected.
He was here.
He was in, but sorry, I need to get my charger. So in general, in the application, you need to explain what you want to do scientifically, and you can give an example how you do it in your lab or how you usually would do the experiment. But it is clear that. Wait a second. Use this one. One second. I need to disconnect what I'm sharing. I need to see if it works if I change it. Can you hear me?
Yeah.
Apologies, we are having some technical difficulties. I'm just going to hand over the.
So my laptop just crashed when I switched on the power supply. So something that can also happen aboard. So explain in your application what scientifically you want to do. Also how you would do it, like in your setup in your lab. But then there will be a second step. So after the experiments are selected, they will need to go through another application for the payload development part, and there it will be discussed with you how to do this.
Okay, great. So there will be help. I don't have to imagine how everybody does the experiment, right?
Do you want to try to complete?
Can somebody maybe speak online just to check if the sound is working?
Yeah, it's working.
Testing, test.
Okay. Okay. So did it answer your question?
Yeah. Thank you.
Okay, great. Let's see. Who's next?
Julia, this is Enrico. Can you hear me?
Yes.
Yeah, just one go back before you were talking about the delivery of the hardware at L-3 months, but it's actually more like L-4 months.
Oh yes, sorry. Yeah, sorry. 4 months before flight. So, can someone see who has the next question? I cannot see it. Whose turn it is? Yeah. Ursula Lavrinovic.
Yes, hello, thank you. Thank you so much for the meeting. So I have a question. If we have to focus only on the short-term missions, or can we also include long-term missions in the proposal? And also, can we sample subsequent missions, not only this one with the participation of Polish astronaut, but also further missions. Especially, we are not including in our experiments any payload or anything like that. We are just interested in collecting samples from astronauts prior to the mission and after the mission. So is it possible to apply also for the participation in the next flights?
Okay. So you can apply for everything. So generally you can apply for everything, but of course it depends a lot what you really need. So we are committing to one astronaut right now. Let's say, okay, we can do human research with this one astronaut. We understand that there are a lot of scientifically this is not really so interesting if you really want to do some human research. So put in how much you would need. It depends a lot how intensive your experiment is. So, if you want to have one saliva swab from 6 astronauts, it shouldn't be a problem. If you have a human research experiment that needs 20 hours of crew time and you need 20 astronauts, then we would say no. And so it's not excluded, but of course, the more subjects and the more intensive it is, and the lower is the likelihood that we can support it.
Of course, thank you so much.
TTA Tekatra. You're still on mute. Yeah, we cannot hear you. Sorry, and I think no one can. Yeah, you don't look muted anymore, but we still cannot hear you.
Can you hear me?
Yeah, now it works.
Is it better?
Yes.
Yes, can you hear me? Yes, perfect. Sorry for that. So firstly, can you please confirm that the total weight of the load that can be taken to the station is limited to the 10 kilos?
We can hear you, but the quality was very bad, so we could not understand it.
What's the weight limits for the load to be taken to the station? The total limitation.
So if it's for the Axiom mission, then the limit in total for everything that we can upload is around 10 kilograms. And I think you need to mute because we get an echo. If you have something that is bigger, it could be uploaded with another flight. but then of course we would need to see if it could be ready for this mission, or if it, and 10 kilograms for everything, for all the payloads together. So really big things would need to be uploaded with another launcher. So either you would need to have an experiment outside of the Axiom mission, or you would fly before to be in time, and then you have even less time to prepare. And we would need to see if we find a compatible launcher and everything. Okay. You're muted again. Sorry.
Can you hear me now? That's strange. Am I mute?
We can hear you. We hear you.
So we are going to send the device, the particle detector that needs to be mounted outside the station. However, it needs to be pressurized. The pressure should be something 1.5 bars. Is it a problem from a technical point of view?
And how many kilo did you say?
The weight about 2-3 kilos in total.
So from the weight, it should be fine. You can have a pressurized upload, but we would need to understand how you want to be pressurized outside. You're mute again.
The point is that we want to pressurize the device on the ground and send it filled with the gas already. And additionally, if it's possible, can we send additional tank, small one, about 0.1 liter, filled with the gas at the pressure of something like 5 bars, just to, as a spare, just to fill the detector just in case. Are there any special requirements for the pressurized bottles?
Yes, so we would really, I mean, we need to look into detail about the safety limits and the safety measures that needs to be taken in place. I mean, yeah.
However, it's possible, yes?
It's possible, but it is very complex. Yes.
Okay.
It sounds very complex, so we would really not look into detail in your proposal and see what is possible, what are the safety measures, and how to implement it operationally. Because I did not understand if you need to repressure outside from a bottle or something, or we would really not look into it into detail. But not excluded by what you was just saying.
Okay, thank you.
Okay, Agnieszka Skorupa.
Hello, thank you for the meeting and for all information. I've got a few questions, but I believe that they are also, connected with some information which was discussed. I'm the psychologist, so basically I don't want to send you nearly anything. I would like to, use some astronauts' time. So I need them to fill out questionnaires, and I need them to do something like video diary. And the third issue, I need them to take photographs. And to that, I ask on the chat, you also refer to my question, so thank you for that. To do that, I need a laptop or, I don't know, tablet with camera software. And is it possible to use your software, or should I send some of mine?
So both is possible. So there is a tool that we are usually using for these kind of things. I think potentially you can find it online. So perhaps you can Google it to understand a bit better. It's called the Everywhere app. So there is an app that is meant for medical use and for human research data. So it is especially for questionnaires exchanging medical or sensitive data. and it's usually on the tablet, on the iPad. So crew can also take pictures directly with the connected. So usually there is a possibility to add applications into this Everywhere app by a team. It's a CNES hardware, so CNES software. It's not hardware, it's CNES software. So there would be it would be something there that doesn't sound complicated for the for implementation.
But beside that, I need to install special software. And we do have unique software to face reading because we are working with a special company, and so we really appreciate their software, and we would like to apply for buying license and to install this software, because we would like to propose for future astronauts the health monitoring program and intervention program. Basically, we are doing that. So that's why we would like to compare visual data analysis, like my facial expression and so on, with what I'm speaking and what I'm putting in tests. And we believe that it's very worth future exploration, but the software is crucial. Can it be installed and financed? How do you think so?
Hear me?
I can.
Okay, maybe this is better. In the past, there's been two options for another experiment that wanted to do something similar. Either you can go through the process of getting that app, for example, approved for installation on the iPad, or what we've done for the Danish mission now is taken an existing app, managed to get that company to agree to release the code to the Everywhere team, and they have integrated the functionality of that external app into the Everywhere app. And there are pros and cons. I think the process of getting an external app on the iPads was quite lengthy with NASA. So there will be multiple ways to look into doing that, just based on cost and schedule.
Okay, thank you. The company is very open to discuss that also directly with ESA or NSA, so it's perfect. And they used to cooperate with you. It's Noldus company, so I hope that it will be okay. But one last question, because of course I'm heading, into Sławusz Uznański research, but still, how about proposing that to everybody who are actually on ISS or who will be participating in the future missions? Can I put that into the application form in somehow? I don't know.
You can put in how many subjects you would like to have in your study. So you cannot just say everybody, so because you need a limited number.
Yes,
you need a limited number, and to understand medically what, you can, at the moment say one is required. It would be the Polish astronaut, and how many would be desired subjects. It isn't, you have seen the medical process for the medical boards. So for example, for the other crew members that are already at the same time on the station, this has already been, it's already in work. So they are kind of not really reachable anymore. But future astronauts might be, but then it depends again how much resources would we need to provide this or to offer this to more crew members. Because of course, every crew member can only do a certain amount of human research. There's the ESA human research, the NASA human research, JAXA human research, Canadian human research. So and other national contributions that want to have subjects. So this is more or less why we cannot really commit to something, and we would need to see how intensive is your experiment. Is it in competition with other experiments? Can it be easily be done? And how much resources would we need? But you can edit it. It's not excluded.
Perfect. So for now, Sławusz is only filling it out, and Sławusz is only using one computer for this mission, for the next mission.
Yeah, he would have, every crew member has a personal iPad. So every crew member has an iPad with this already mentioned Everywhere app on, and on this Everywhere app, he would have access to what you would need, and it would not be a problem to have the same, let's say, for other crew members on their device.
Okay, but not on this mission, but on the future missions.
Potentially, yeah, rather on future missions.
Potentially.
It can be. It always depends. We are it depends also who's flying on the same mission, for example, from the other Axiom private astronaut mission. So we can offer human research also to them. Sometimes they're interested, sometimes not, but it's also not excluded. Yeah, and also for for the crew members that are already on board, I think it is crew 8. Yeah. So they have their, they already had their informed consent briefing. So it is really difficult to still get them.
Of course. And during one mission, it's how many astronauts? Because Izabela Krzeminska also asked that on chat. So how many astronauts will participate in the mission? In the same time.
So there are 4 astronauts flying on an Axiom mission. So you usually have, our ESA astronaut, then you would have 2 more private astronauts and 1 career astronaut from Axiom, who could theoretically also participate. So there are usually 4 persons on an Axiom flight, and on top there are 7 more persons on the station. So
thank you.
Yeah.
Thank you very much.
And then we have Katarzyna Pilewska.
Yes, hello. Hi. I have a question that might be actually overlapping some of the other questions. Already posted that in chat, but maybe I'll ask it now. Because while writing the activity requirements document, we came up with several questions, mostly very specific and detailed about packing samples, mounting samples. Do we need to prepare and develop sample holder beforehand? And if I understood correctly from your presentations, we even before acceptance, we need to only provide our requirements for the scientific part, what we need to do, and the details, know-how, how to pack, how to mount samples, or is it a tape or a Velcro or whatever else is to be decided while the integration stages are going to
you don't need to have answers for these questions in your application. Yeah.
So if
you have an idea, you can say we assume that it might need to be put on a holder or attached somewhere, but you don't need to explain how.
Okay, so if still within our scope of our research, it will be decided that, for example, some parts of the experiments are not possible to integrate in the Columbus module. Does it cross out whole experiment, or is it possible to make just partial if it's not necessary to make it whole, or it's either all or nothing?
Yeah. No, so if there are things that for you are you can put in information what is optional and what is a requirement. If there are things that needs to be done, otherwise your experiment does not make any sense anymore, clearly mark it, and also mark these things would be an optional thing that would not, I would still have interesting science or things like this. So if there's something, you can add some information already, and if we see that only a certain part is not possible, we can come back to you and discuss it instead of saying that the whole thing is not feasible.
Right, and it is during the assessment process, or just after acceptance?
We will do a feasibility assessment during the acceptance process. So once we see all the we need to go through all the applications from POLSA and ESA together, see what is feasible. Scientifically interesting, feasible, what is within the guidelines that we provided from ESA, what is feasible from the budget point of view, what is operational feasible. So we will look into these things before accepting. If we have questions, we will come back to the teams. It's not that there will be no communication. We can clarify with you if it's some things are not sure. So we are open to this, and and then we need to see what is a good complement and how can it all be a good mission together as well. I mean, so I don't know. We have a lot of people here today. If everyone is coming with an idea, then of course we cannot do everything. But so it's during the application that we check.
Right. Okay. Thank you very much.
Yeah.
Thank you.
Okay. Real research.
Yes, hello, thank you. Hi again. Actually, I have a different question, but I want to specify the one before in terms of the optional part. Is it like, because everything is bound to the budget. So we have actually the same thing. So we have something that we really want to do, and this is actually very easy and very straightforward. And that's about the cell culturing incubators. But there is also part that would physically be connected to the IC cubes. We know the parameters, everything is fine. How to structure that? I mean, in terms of the budget as well. So we have to plan for how many people, what has to be outsourced, what will be done by other companies. Like in which part of the proposal should I say this is what I really have to do and this is the most important, and which part is the optional version? Where in the proposal is a place to do that in your understanding? Julia, you're muted.
Yes, sorry, I was checking with Angelique. Angelique, you want to answer that?
Yes,
yeah.
Yes, so I think the best thing to do is to fill this in the ARD and to mention this in the scientific requirements. This is probably the best spot, but as Julia already outlined, if we do have additional questions or if certain things are unclear, we will reach out to the team. So maybe this is also a general comment to everybody who's planning to submit something. If we do have questions, please keep an eye on your mailbox in, let's say, the week or the 2 weeks after, because then we can have a short communication between us who might have additional follow-up questions and yourself, just to make sure that we have everything in place before we can make a final selection and a well-informed decision on which projects are feasible to move forward.
Okay, so that's going to be that was the follow-up question, and the real question is actually, I think you already answered partially that question in the Q&A on your website, but I spoke to the partner and there is an iteration of the question. So we have a Canadian partner. This is not the most crucial part of the experiment, but this is actually a very interesting add-on to the experiment. From the intellectual property perspective, they should be a co-partner. But we could think about them as a subcontractor. So as a subcontractor, I think we could pay them for part of the work they would be doing. But as a co-partner, I'm not sure if we would. So what would be your advice to be able to put a Canadian partner we would be the leader as a Polish company, but how can we include a Canadian company and be able to pay them maybe as a co-partner or as a subcontractor? What's your suggestion?
What I would suggest is if they are involved in both, so if there's also a scientific, let's say, component to their involvement, I would mention them as both as a science team member and as a subcontractor. To be honest, I think we need to discuss with POLSA on how this can be funded, but I would not exclude it from your application because there might be other opportunities to fund that potentially through the ESA member states. Maybe they want to fund that part for their scientists. I think this is something we need to then discuss. So for now, I would suggest include it, and we can then assess it later on to see how it's being dealt with. So I think this in general applies because we've seen many questions in the chat as well on which costs can be eligible for funding and which not. Again, we need to clarify still some things on that internally and together with the Polish Space Agency. For now, please include everything. Just be very clear for what the costs are and include in the budget proposal. And then we can come back to that later on which costs are eligible for funding.
Okay, thank you. If I can quickly jump to, like in the application, the point 2.5, there is a table, and I'm really not sure how to fill it in. It's a mission, platform, year, duration. It's like we have not done any mission like that before. Should I just leave it empty, or like what should I do in that part?
So can you refer again to which part
in
you
the
are?
ARD file, the point 2.5. There is a table, and I'm not really sure how should I, like, what should I put into this table? So what do you expect people to put in under mission, platform, year, duration, and
no, okay, clear. If you have no previous or ongoing activities, then you can leave this empty.
Okay, okay.
Yes. So
okay,
that's just
clear.
More, yeah, if there is no precursor, then that's perfectly fine. Then you just leave it empty.
Okay. And then in terms of there is a table about on page 13 about parameters, downlink sequencing, downlink data. We would like to have some temperature profile, for example, or the CO2 profile. From the discussion, I understand that it's actually us who should write in how often would we like to take it. The thing is that we are actually quite flexible. We would like to have like every hour, let's say, read out about the temperature and the CO2. But if it's going to be every 6 hours, it's going to be doable as well. If it's going to be once in 2 weeks, that could be not enough. But what is the bandwidth between the ISS and the Earth?
What I would suggest there is to indicate what you desire, but give a, let's say, range of what would be the minimum that would still be acceptable for your experiments. And then we can work with that. In general, we work on a best efforts case basis. So we will do to try and deliver you as much as we can, but sometimes there are, of course, limited resources. And then we will just go with your more strict requirements. So I think it's most important that you give ranges, and this also applies to others who might be interested. Just give ranges on what your minimum and your preferred is, and then we can take that into account. For the second question, I'm going to refer back to you on the data.
Yeah. Data download.
Okay. And there, yes. So there is also a 0.6, like ground reference measurements. Should I understand it as the measurements that will be done on Earth in the same time, or how? Because in our case, there will be like a experiment at the same time on the ISS and at the same time on Earth to be able to compare what's going on. Is this 0.6 ground reference measurements about that, or is it something else?
No, that's about that. So that's exactly what you need to say there, that you will do the same at the same time in your on ground and to compare it.
Okay. So my understanding in general from this whole webinar is that you actually are pre-selecting the ideas, and then you're going to make sure that these ideas that are most interesting are eligible. Because I have 50 questions about the budget, about how it's going to be structured, about the overhead and things like that. But do I understand correctly that you're going to choose the ideas mainly on the basis of the quality of the idea and whether it fits to the general purpose of the grant, and then you're going to decide like how to make the most out of them, or how are you going to judge those applications?
Yeah, I think in the AO there is a section that shows how the evaluation is done. If you see it, you can share it. Yeah, Angelique will share it in a moment. So all parts are important, of course. So these are the evaluation criteria that we will use. So of course, it's a 50-50 question. So no, it's what is technical possible and what is programmatic. What are the programmatic criteria?
Okay, because for example, the clarity of the technical objectives, to me, this means that I have to write a very clear step-by-step set of experiments. But from the discussion, I see that actually once we write them, we're going to have a discussion that something is more, let's say, more eligible or better for this set of experiments, and then finally, let's say, kind of from the discussion, we will decide together what will be actually done. So the clarity is like, I can make it very clear and extremely precise, but that's going to make the budget also very precise. On the other hand, I can make it much more open, and then the budget will be also a bit more flexible. So I'm trying to get, because I see that you're very open to different ideas, and that's fantastic. I just want to understand how precise and how much planned to the minute it has to be, or how open.
Yeah. Okay. I'm from the technical side. I would like to have it more precise, but I let Angelique answer for the scientific point of view. Might be the difference.
Yes. So, I mean, you ask a very good question. And I think in general, the answer is be as specific as you can be. This makes it much easier for us to assess, although we do understand that there's a specific time pressure. And I also understand that this is a very new community. So we also want to be quite flexible. So the recommendation here would be as specific as you can be. And if you are flexible, indicate that with margins so we can look at both the best and the worst case scenario, so to see. But we do understand that we might need to do some iteration. And to be honest, for all of our announcements of opportunities, especially with those where there is development involved, it's always an iterative process. So after we've done a first selection, we will always go back to the science team, discuss certain criteria. If there are things not possible, we will look for other compromises or solutions. So please take into account that whatever you submit is not set in stone, and there will be some discussion also later on. But if you are already very clear, and that of course would be ideal on what you want to do, please indicate that, and then we take it from there. If you are more flexible or you're unsure or you want advice and you give a specific proposal on something, then that's also okay, but then we can take that into account. So I think it's a bit, yeah, we prefer to be as precise as possible, but we do understand that this might not be possible for everybody at this stage. So we also want to be flexible in that regards. I hope this answers the question a little bit.
Yes.
Thank you.
So I know I already stole a lot of time. So the last one, what is the total allocation? How many grants do you see to give out?
Experiment. Oh, that's interesting. It's really difficult to say because, of course, if we choose one that is really complex, needs a lot of support and a lot of money, then it might be equivalent to 5 small ones or something. I mean, it is really, this is really difficult to say. So we really need to see.
What is the total budget allocation for those, for all the applications together?
Yeah. So perhaps this is not the right, I mean, I don't know if POLSA wants to say something here, because then it's more a POLSA question.
Yes, maybe I can take that question. We have some flexibility here. As I indicated in the beginning, this is the first time we all are doing this exercise. So this is the call for ideas now. So we want to collect all the ideas. The overall the overall the possibility. Well, we didn't want to put a fixed price of the experiment because this is always a trade-off between the quality of the research and the cost, the investment that has to be made. So, of course, reasonable, in line with the Polish subscription to ESA, and subject to the quality and also the following follow-up discussions. So we don't have a fixed amount here.
So I know that there's not a fixed budget per project, and one project can be up to 1 million. I understand the 1 million is not the one that you look for, but how, like in total, the whole budget for everybody, like let's say, are you planning more or less to have 10 projects, 500,000 each, or is it 50 projects, 200,000 each? Is it like, I'm just asking for the scale more or less. What is the expected number of projects you want to send to the ISS?
Oscar, I can see that you raised your hand, and I sincerely need to apologize you and leave the meeting now because we are having another meeting with NASA on the Artemis program starting at this very moment. So let me take this. Oscar, I give the floor to you. Also, Marta Balcer is there from POLSA, and she is recording, and she will be there until the end. We will try to take as many questions and try to answer them now, but since there is still a lot of people waiting, please be sure that we will answer them either now on the meeting or later on the individual basis. Thank you all. Thank you. Bye-bye, and Oscar, floor is yours.
Thank you very much. Thanks, Alexandra. Yes, I would like to address this question. It's closely related to the question on criteria earlier. So just wanted to emphasize that what we are doing here, we are not giving grants. We are investing in most worthwhile technology verification tests that will enable Polish industry to go to the next level, to take advantage of the increased contribution to ESA, and to be able to commercialize technologies, develop new product lines. And this is very much an exercise to bring Polish technologies a level closer to the market. That's the top level goal of the exercise. Therefore, what we are not doing is we are not giving grants. And related to this is what Alexandra said, that it's that we don't have a specific funding cap. We will not specify what is the limit for one particular project. What we would like to encourage you, the Polish space sector, is to develop ideas and describe these ideas to ESA and to us. As it was emphasized many times during this discussion, we will not chase you after the details if you don't know the details. We do not require a step-by-step procedure to be able to assess on the two criteria that were presented to you in the EAO. It is not about about how precise you are in addressing these criteria and how much detail you provide. Is about how well you fit within the scope of the call. So on one hand, it is feasibility, yes. The majority of the discussion today was to do with feasibility. It is an important question, but the second half and the second criterion is about how this particular experiment will help the company, will help the space sector, and will bring Polish industry closer to the market. So I would like to emphasize this, that this is the objective, and therefore and this was also emphasized by ESA many times, we encourage you to submit your proposals, to describe them as well as you can, and describe the benefit that will be achieved through the experimentation that you are proposing. If there are, if in some areas you do not have sufficient information, that's fine. But please do not focus on the minute details. Focus on the big picture and fitting within the idea of the general call. So that would be my advice. Please think about the project first. Thank you.
Okay, thank you very much.
Yeah, thanks a lot, Oscar. And we are running out a bit of time, so let's try to go through the 1, 2, 3, 4 more persons that are in the queue, and then I think then we need to find the end of the meeting. So Marcin Kowalik.
Hello.
Marcin.
Can you hear me?
Yeah.
Okay, so I have an idea for the experiment, which is very simple to make. I want to send some samples of novel material, which is very small, to the ISS, and you can put it into the paper, the cover, and you have to put into ISS for 3 months or more, and to allow it to influence with cosmic radiation. The cosmic radiation will damage this novel material and will change its properties. And my group want to see what properties will be influenced by cosmic radiation. And I wonder if you can tell me what is the hardest point to make this experiment happen. So it's not dangerous material for people. So
yeah. So just to say, so the samples will be quite small, and they just need to be exposed inside of the station.
Yes, inside in the stations for a few months.
Yeah, as long as they are not toxic. Yeah, as long as there's nothing toxic, I don't see any big difficulties. Sounds quite straightforward.
And how you
toxicity?
Toxicity of the material.
Yeah. Is the toxicity table online publicly? No. So there's a team at NASA who is checking all the toxicity levels from all the items. So if it's new material, it might not be in the list, but then they will get the information from us. So you will tell us what is in, and we will share the information with NASA, and they will do testing and then define the toxicity level. And depending on how toxic it is, if it's not toxic, then you can
touch it and grab it by bare hands. So it's
usually if it's not toxic on ground, usually it is not on board except for outgassing reasons. But then even if it is rated tox level 1 or 2 or something, then it can be put into a container that it cannot go outside, and the cosmic radiation should still go through. So it shouldn't be a problem. So it looks quite easy to implement, let's say.
Okay.
From first glance.
How long you can keep it on the ISS?
Yeah. Also there you can put in what is your preferred requirement, what is your minimum requirement. You could have also say like 2 samples, one stays 3 months, one stays 6 months. Let's say the current end of the ISS is 2030, so it should not be more than 7 years.
Okay, so it's possible to apply to 7 years.
Yes, it's possible. If it's not too big, yes.
No, it's one sample or batch of samples is the size of credit card, so it's very lightweight. Okay, so thank you.
You can put this in. Okay, thanks a lot. So we will go to the last question, I think. Wojtanowski Jacek.
Thank you for the floor. One short question. What kind of certifications do the hardware need to have to be allowed for ISS experiments?
Okay, so so you need to have a safety certification from ESA, and so we need, in general, we need to know all the material that is used. So everything will be checked versus toxicity. Then it needs to be checked if it's safe to handle it. If it does not have sharp edges, so that the crew cannot get hurt by the experiment or by the hardware. That it's safe to operationally in general safe, so that it cannot explode and all these things. The things that you also have in planes. All these things will be checked. These are the main things, but there are clear rules, and you will get then the documentation where this is all listed.
How long does it take to follow this process?
Yeah, and this takes quite long. So this is one of the major concerns. Oh no, that is not what I wanted to share. Sorry. This is one of the major concerns that we are having. So it usually, I try to bring up the presentation again because there was a timeline. It depends on the complexity. Second. So what was the quickest, what do you think, what is the quickest safety process review you had ever? Oh, yeah. 9 months. Yeah. So if it's really, really straightforward, really simple, we're trying to see what is the quickest you can have. Huh? So because here you see we assume that you start with a process for safety, because safety is really one of the most critical, most intensive ones. For hardware. Yeah. Yeah. So if the moment you have hardware that needs to be certified, so I assume, since it was your question, we think 9 months is what we use. If you have something really complex, it will be more. So we have things that, I mean, of course, these things then also need really long payload development time frame, so years. So then we also have the safety running for years. But assume 9 months if it's a decent complex experiment with hardware development.
So we should start to do it right now, because we are having a start of the mission in 9 months time.
Exactly. Yes. So the moment this is also why we are a bit reluctant to enlarge the time for the applications, because we know that we really need to start. So the moment we close the call, and then we will go and check the applications. We do the candidates will be picked. We will go ahead right away into these processes. So it will be really time intensive and a short time frame, and it would start right away. I mean, as possible.
Julia?
Thank you very much.
Julia, maybe it would be, I don't know if you've already done it, but maybe it would be a good idea that we already send them everything that is required for the safety team, so that maybe they can already start putting those things together if they have most of the information at least available, at least so that they know what they have to provide.
Yeah. We need to see how we can provide the information. I think for some people, we provided already information in the OSIP tool when it was requested. The problem is a bit like, I don't know how many applications there will be. So if we have 100 applications, and in the end, it might be not worse for all of them to go ahead with this. But of course, we can see how we can share this documentation as soon as possible, at least. Okay, let's have a last one, Jakub Miczkowski. Yeah, and then we need to close.
Thank you. Thank you. Thank you. I have just a really quick question, and I just want to double check. Do ISA or maybe it's also a question to Oscar, because maybe POLSA has a different opinion. Do ISA or POLSA care whether the application will be from company or from university? Is it important?
From ISA side, no. In my understanding, I mean, Oscar, if you are still there, don't see the list of all participants. Yes, you want to answer for? Yeah, you can answer for POLSA. Yeah.
Yes, I am. And
no, I think because you just mentioned the investment, and that's why because usually there is a different pathway for the product from university and from the company. So maybe it's
okay. So what we encourage is we encourage the submissions to have a industrial application in a realistic time frame. And for the purposes of the submissions, it doesn't matter if the submission comes from a university or an entity within the, well, it can be any entity within the space sector. It doesn't have to be an industrial entity. Thank you.
Okay, perfect. Thank you.
Okay, so I would propose to close. We're already running over. Go ahead. We tried to answer a lot of questions already in the chat during the meeting. So if there's something that is still not answered, put it in the OSIP tool or get in touch with Marta or someone else from POLSA or with me. And then we try to close all the questions before the closing date of the application. So from our side, we wish you all the best, good luck, and we hope to work with most of you soon. And I don't know, Oscar or someone else from POLSA, if you want to add some words before we close today.
So from my end, I would like to say a big thank you to ISA for organizing this workshop, for giving all the information and answering the questions. I know there were many, and I think there are many more in the chat. We didn't manage to go through them live, but thank you so much for your time and for preparing all this material for us. I would like also to thank the space sector for your interest and enthusiasm. We can really feel it, and that's wonderful, because that's why we do it. We do it to grow this Polish space sector. So it's great to have you with us. Please submit your submissions, your ideas in the OZIP tool. And with questions, please direct them either to through the tool to ISA, or if there are more specific questions outside of the topics that can be addressed in OZIP, or you can also direct the questions to POLSA, as we are the interface on the Polish side. So I would like to thank you again, and I would like to give the floor to Marta, who is deputizing for Alexandra. Perhaps Marta would like to add something, to a few words to as a closing. Thank you.
Thank you. Thank you so much, all the participants, for joining us today. I will collect all of the questions from the chat, and I will pass it to Isa. If they were not answered, they will be answered soon, hopefully. As we mentioned, the video will be recorded and uploaded to our website. So thank you so much for the participation. Thank you, Julia, and your team for the great workshop. I truly hoped it will be helpful for all the applicants, and good luck, and thank you very much.
Good luck. Bye.
Bye.
Bye-bye.
Bye.
Thank you. Bye-bye.
Bye.
Thank you for the meeting. Have a good day.